Okay, in this section we're going to try to figure out, we have 5 verbal descriptions where we're going to try to match the graphs above with each verbal description. And I think the best way to attack that is to look at each graph and get some kind of sense of what it tells you. Now this is a velocity versus time graph. All of these are versus time. This shows constant velocity, so it stays at the same speed, and then trending away from 0, so it speeds up. Gets faster. This one shows it slowing down. It's also a velocity time graph, so it's trending towards 0, so it slows first, and then it speeds up. But as it speeds up, it's on the other side of 0, so that means it's changed direction. Now the slope of that one is constant, so that's constant acceleration. It's slowed down and then it's sped up in the opposite direction. Coming back down perhaps is a possibility. Let me go look at D again, because that's also a velocity time graph. Flat line means constant positive velocity. It's in the positive section. And then trending towards 0 means slows down. Now that would indicate that we have a negative slope or a negative acceleration there. Over here we had a positive acceleration. It was a positive slope. Now position time graphs don't tell us how fast we're going. They tell us where we're at. We're at the same point for a while here, so that indicates we're at rest for at least a portion of the motion. Then we get a parabolic curve, which means we have acceleration, and we're getting faster because it is becoming steeper. The slopes are becoming steeper. Since we have positive slopes that are getting steeper, that's going to be positive acceleration in this case. Now the other position time graph, 2 straight lines, so when the lines are straight, we have constant velocity. This case, it's faster, steeper slope, and then slower, more shallow slope. So this one went faster and then slower, but always moved in the same direction. So let's check the descriptions and pick some out. The object is moving fast with a constant velocity, and then slows down with a constant velocity. It moves slow with a constant velocity. So we need 2 different constant velocities. The first one faster, the second one slower. 2 CVs, 2 constant velocities. The first one faster, the second one slower. Looks like graph E should cover that. In B, moving in one direction with a constant rate of acceleration, slowing down, changes direction and continues in the opposite direction but speeds up. So slower, then speeding up, opposite direction. That would be letter B, graph B. Constant velocity and then slows down, constant velocity and then slows down. That would be letter D. Constant velocity and then speeds up. Constant velocity, then speeds up, trends away from 0, that would be letter A, and then remains at rest, and then accelerates, or speeds up in this case. Accelerates could be also slow down, so the graph could look like this. Not like that. The graph could, in fact, it would be hard to slow down from rest, so forget that idea. We'll just say that it's going to be accelerating, and it's going to be speeding up from 0, from rest. And that makes this letter C. So, again, don't try to say read the description and then go looking for one that might match it. It is much quicker, much more effective to jot down, find out, read the graph, okay? Read what it tells you, and then go looking for the one that will fit the description. That's a much better way than trying to read a description and then go looking for something that might match. Especially when you have multiple graphs there. You have velocity and position. It's easy to confuse those two and then get totally off track. So read the graphs first, then look at the descriptions. You'll find it's not very difficult. That's the end of this part. In the next part, we'll look at how this might combine with motion diagrams and the strobe photos that we've been looking at, and a little bit to the idea of video analysis.